Question 20. We can start off by identifying some equations that are relevant to this calculation. We have the equation for the capacitance of a parallel plate capacitor. We also have the equations for the equivalent capacitance for capacitors in series, as well as for capacitors in parallel. We will break up the capacitor into two subcapacitors that are the region defined by the inner disk, in which the dielectric material is contained, and the outer disk, in which only air is between the two plates. And finally, we can use parallel and series relationships to calculate the equivalent capacitance of this system. Subcapacitor 1 is the outer disk, and subcapacitor 2 is the inner disk, and they can be thought of using this circuit diagram. Subcapacitor 1 and subcapacitor 2 are connected in parallel, and the two regions of capacitor 2 are connected in series. First, we will calculate the capacitance of the subcapacitor 1. We'll use the equation for the capacitance of a parallel plate capacitor, and for the area, we will find the area of the outer segment minus the area that we removed from the inner disk. We will then calculate the capacitance of the two subregions of capacitor 2. We will first calculate the region that has the dielectric with dielectric constant 2. We just use the parallel plate capacitance equation. We can then do the same equation for the region that has the dielectric constant of 1 because there is air between the two plates. Once we have these two results, we can add the two capacitances in series to achieve an equivalent capacitance of subcapacitor 2. We can complete the problem by finding the equivalent capacitance of the entire system simply by adding the capacitance of capacitor 1 to the capacitance of capacitor 2 in parallel. We achieve a result of 1.8 times 10 to the negative 9th farad.